This session is about the blind spot in cybersecurity. It's all about APIs, building APIs, securing APIs, just to make sure that you are at the correct session. My name is Sjoerd van Lochem, and I work for Cronos. And I do not intend to explain our internal structure because it's very complex. But it's good to know that we have around 10,000 experts, or 9,000 plus, but nobody knows how many employees we got and how many different companies we own, just because we're that decentralized, organized. We are located in the Netherlands and in Belgium, privately owned, so no strange things there. And on this venue, we are here as Cronos Security, and actually two companies are taking part in this presentation. IHC, Integrate Consulting, that's about application integration, API management, architecture, and security, and SALT, Cybersecurity. So both companies will present itself later on. And just to get a grasp, why is API security such a big thing? First, this is some research by IBM, what the average cost of an API breach is. And it's more than 2 million per API breach, which is, I deem, pretty significant. But maybe the other slide is even more staggering. A large part of the internet traffic is actually API traffic. A lot of companies do own more APIs than they really know themselves. So a lot of APIs are exposed out there and not secured or managed in whatever manner. And the table below states how many API breaches there are per industry. And I think everybody is looking whether they see their own industry, and it's even split out between big companies and smaller companies. So there are some winners and some losers, as in where there's a lot of API breaches going on. If you multiply each by the damage per API breach, you'll see that that will add up to a pretty significant amount of money, but also I think losses you cannot explain in money whatsoever, so image damage, etc. Who we are? Today, the presenters are, first is Samuel kicking off. He's explaining about API management, the role of APIs. Second is Teun. Teun will do actually a life hack and make it noted how easy it is to actually exploit a poorly designed, deployed API, and that you don't need any tool or don't need very much knowledge to exploit it and make use of it in a better manner. And last but not least is Matthias. He's explaining about strategy, governance, and how you can solve things from the root. So, first, Samuel, thanks.
All right, thank you. So first, around API and API management. So I work at IHC, and in IHC we do everything related to integration, which is a very broad space, and it's all about connecting all the systems within an organization. An organization typically exists out of a lot of different systems with a lot of different processes and teams around it, and all these systems do have APIs exposed where functionality or data is exposed. So what we do, we don't build those systems, but we make sure that all these systems can communicate with one another so that we can build business processes on top of and across all these different systems. And one very important aspect of, or here called connectivity platform, is API management. And that's where we're gonna focus on today. So let's take one example, so we have different systems in our enterprise, within our organization. Let's take one example, a professional platform, for instance, a platform who's managing technicians which we can book, which we can plan, which the resource allocations for those technicians can be done. So it's a typical IT system within an organization. We can use an UI to access that platform in a basic way, but typically that platform will also have an API, in most cases today REST API, which also exposes that functionality. A typical use case would be that we want a mobile app or a Android iOS app to access that data so that on the road we can book those technicians, that we can do the stuff with that system that we want to do. Of course, at that point, that API, which is an access point, which is an interface to that system, needs to be exposed to the public internet. So that means that an entry point is created to your personal data, to your private data, your company-owned data, exposed to the public internet. And it needs to be exposed because, of course, we have an app that needs to access that data. So what we will do is we will not directly expose that API, because that is a security. It's a security risk to directly expose that API. So we will put something in the middle, which we call an API management platform, which will make sure that we can expose that data or functionality in a secure, in a governed, and in a well-managed way. And so what we will do with API management is enforce security. So to make sure that only this application can access that API, but also only the authenticated end users of that application who are authenticated and authorized can access that API in an automated way. It's not only the security, but at that point, our app is the product that we offer to customers. So that means that we also want to guarantee the quality of the functionality of that API, because that API is an entry point to the service that you are providing. So we also need to guarantee the quality of that service. It's an important aspect, because if for some reason that API is not responding, or that backend service is down, or there is some issues with it, then of course we have business impact. We don't want that, so we want to make sure that we manage that. So we also have quality of service, things that we want to do in that API management platform. Other things an API management platform can do for us is analytics, to make sure to visualize all the traffic that goes through to the APIs of your organization, that you have full visibility, observability into that platform. And additionally, typically some integration transformations can be done, but we will not focus on that today. But more than that application, what we see more and more, of course, that API can be used by an app, but more and more also by B2B partners. So where they don't want to use that app, but they want to integrate automatically from their processes, from their ERP systems, to automatically book something into our system. So also there, security-wise, we need to authenticate those business partners. We need to manage them. We need to make sure that the security is applied for those B2B partners. And in essence, any consumer should be able to access our API, to use that API in a profound way. And if we do that for any consumer, that means that if we have, for instance, this platform now exposed to 10,000s of different organizations, it's not manageable anymore for every developer of these organizations to also ask for the API keys, to ask for registrations, to ask for the technical details of that part. So with API management, we'll also introduce additional functionality for discovery, to see, okay, which APIs are available, how can I use them as a developer, what is the technical information needed for that API management part, how can I register, who needs to approve when I request an access token, how can I monetize it, because it's also an aspect, so that you can use the analytics to monetize the usage of that API. So a lot comes into place when we talk about API management. And that's the full breadth of API management when we look into that aspect. So it's way more than just security, but security is a very, very important aspect of it. It will not fix all the security issues for exposing an API. So just to make sure that that's also clear. But here we're really talking about application level security. So on top of that, you will still need to have network layer security and other levels of security. If we look at it a little bit deeper into that, one of those platforms, and that's, I think, many organizations are using API management platforms and API gateways. Not sure here in the room who knows that their organization is using such a platform. All right, some. Such a platform exists typically out of some basic blocks, some basic components. The most important component is the API gateway. The API gateway is the thing in the middle which we will put between our applications itself and the consumer or mobile app or any consumer that wants to access our data. It's a kind of reverse proxy that will do a lot of policy validations for an incoming traffic before sending it through to your backend system. Next to the gateway, we also have a developer portal, which is a separate deployed system, which gives developers of any organization access to the list of APIs that we have, that we expose, and how to access those APIs. Then, of course, we have a means to also manage all these APIs, which is typically the API manager. And then we have the analytics components, where we want to centralize all the analytics generated for the APIs that we are exposing. If we look a little bit deeper into that API gateway component, how should we visualize that? What does that thing now actually do? And for that, I try to visualize it a little bit. So we have an inbound call coming in to retrieve to do a booking, for instance, into our technicians platform. Before we want to send that to the backend system, we first want to do a lot of validations that we can guarantee that on an application level, that request is valid. So what do we do? So we can check on size, on course. We can do rate limiting or throttling. So for instance, if your application is pen tested and it can handle 10,000 requests per second, but at a certain moment in time there are 15,000 requests per second are coming in, you don't want to have them all sent to the backend system, because then your backend system is down and nobody will be able to use it for the coming 20 minutes because you have downtime. So we want to throttle the incoming traffic, so that we are sure that's the maximum point that our backend system can handle. We want to, for instance, do IP checks. If we only have B2B partners that we only, for instance, allow the IP addresses of the B2B partners that are onboarded onto our platform, so that we can have security measurements. Can also be mutual TLS, can also be certificate-based authentication, so there are a lot of measurements there. We can do token validations, so that the token that is provided by an identity platform can also be actually validated. Also, we can check that the signature is valid, so that it is not tampered with before accessing that platform. And so we have a lot of things that we can do. Caching, also a very important one. Again, to offload our backend system. It's very difficult to implement caching in every backend system in an organization. If our API management layer can already do that, it can again offload a lot of traffic for that backend system. And then we have validation, transformation, some integration logic that can sometimes also be applied on API management. All right. To do that, of course, we need software. We can build that ourselves, this software, but typically we have software vendors, technology vendors who provide us software which can do API management. And we have quite some examples of that. So like here this is Apigee, Google Apigee, which is an API management platform that we support, but we support a lot of them. I will explain that later. Which for all the services in the Flemish government, I'm a Belgian guy, apologies. For all the services in the Belgian government, they will not be exposed directly, of course, onto the public internet, all those APIs. They will go through an API management layer, which is Apigee, which will then do the validations which we just talked about before going to the different applications that the Flemish government offers to their citizens. Same in the Port of Antwerp. If I drive in with a truck in the Port of Antwerp, I need to register that I want to pick up a certain container. I have a mobile app for that. Of course, that mobile app has very secure. It needs secure data because there is a lot of security issues in the harbor around the, for instance, drugs and the things like that. Also that application needs to access internal data, but that internal data is again secured by an API management layer here. Software AG, which was recently acquired by IBM, but again an example of a API management tooling. And what you see here is on the right side the interface which you can use to do the full configurations of all the policies that I just explained. So it's not something that you need to code each and every time, but it's something that can be configured onto these platforms. And in that area, if you're looking into different vendors who can provide such a solution, we have a lot of them. I'll quickly jump to let's say the analysis of this year. So we have a lot of vendors like Google, like IBM, like Kong, like Xway, who provide these types of solutions. What we do as IHC, what we can help you with, because they all have their own strengths, to really look into your organizations, what are the requirements your organization has for API management, because that depends on each organization, and then see which type of technology best fits your organization, so that we can also do a product selection on that area. But what we are seeing today is that the whole story that I just brought is quite an old story. It's, I think, 10 years ago, we really started to adopting API management, because 10 years ago, we really started to exposing APIs to the public world. In the last 10 years, a lot has happened, which makes that this basic model became even a bit too basic for many organizations. And for that, we see a lot of, let's say, trends. We see a lot of changes in our landscapes, in our IT landscape, that make that we need to revise, let's say, our API management platform, that we need to look into, okay, how is that evolving, and how do we, as an organization, but also as a technical platform, adopt to those new changes that there are today. And I will not be able to focus on all of them, but if you're interested in on any specific one of them, please reach out to me after the session, and then we can certainly discuss further into depth. So I'll show it here for a bit. Very briefly, so I spoke that we started with the REST API. That's the most basic API today used. We also in the past had SOAP APIs, but there are more and more protocols and formats that our API management needs to support. So today we have GraphQL coming up. We have a lot of event streaming and event streaming interfaces that next to our classic APIs, also systems need to expose events. So for that we have Kafka protocol and async API coming up. So also our gateways need to adopt those new protocols and need to make sure that they can cope with them. Another thing that has evolved a lot, so I think in the Netherlands even that has evolved already more fast than in Belgium, is that our architectural landscape gets more and more complex. So where in the past we had just our on-premise data center where our API management could be deployed, today we have our on-premise data center, we maybe have Azure Cloud, we have Google Cloud, we have AWS. All our workloads are scattered around all these environments. So also our gateways need to be scattered around these environments. So that means that we need to evolve to a multi-gateway landscape. And a good example here is in our middle layer, we can have a centralized gateway where we can expose those APIs. But maybe we have also an AWS environment where we have another gateway exposed, again, exposing different APIs of different services on AWS. Maybe we have a microservice environment, which again has its specific APIs, which also needs a specific type of gateway. And so we can have a lot of different gateways in an organization. And today we can even have a lot of different gateways from different vendors in an organization, which makes it even more complex. And so we see that those API management platforms today are really more and more adopting the pattern where we can have one control plane which manages a multitude of different API gateways, even of different vendors. And that's something that now in the last couple of years is really popping up and as a requirement more and more. Another one, of maybe one more thing on the gateway there. Not only on the gateway, of course, if we think about that developer portal, that unified interface where each developer needs to log in to see which APIs are available and which technical details are available for those APIs. If all those APIs are scattered around different API gateways, also there we need to make sure that we need one portal, one developer portal, where is your marketplace, let's say, for all the APIs that you expose. That portal is also able to expose APIs from different vendors and from different gateways. That's what we call a federated developer portal platform. All right, so that's for architectural complexity. Then we also have new use cases. So in the last, again, 10 years, we really focused on synchronous APIs. So I send a request to a system and it answers me directly to provide me feedback. Now more and more we have interfaces which just sends out an internal stream of events, and that has new protocols, but also has new ways, new use cases that need to be enabled for our API management platform. So that's an important one. Also, that's an important trend which we also see is the exposure of LLMs. So many organizations today are working on are building AI models on top of their private data, on their enterprise data. They are training their own AI models and their the AI models on top of their data. Of course, they want to expose that LLM to the outside world sometimes. And if you expose that model to the outside world, again, you are exposing typically, privately custom data. So again, you want to secure that. You want to make sure that not everybody can access that. And so our API management platforms not only need to support standard applications as a backend, but now also need to support LLMs as a backend, which again, we need to secure and govern the way it's exposing that data. Another last trend which we see is API security or advanced API security, which I already showed is that our gateway has a lot of policies which it applies when a request comes in. And so if that request that comes in is not valid, it will block that request and send out an alert so that we can act upon that. But of course, there are also a lot of, let's say, attacks to our APIs, which you cannot stop in one point. So now what many of those vendors are doing is to store all the requests and replies coming into that platform in a centralized data store, and there do anomaly detection onto that data that's centralized, again using AI models, and then see if there is abnormal usage of data. So for instance, if every day at a certain time a Russian IP is calling your API, not in an invalid way, but a bit in a strange way. That's a pattern that can be detected by an AI model, and then it can act upon that, and it can inform you that probably you should take action. And that's again a new trend that we see to further enhance our security model. And again, there are some vendors who support that, but most of the API management players on on the quadrant which I showed already provide first integrations into that part. Voila. But with that, I can close off the first part on API management. So what we see is API management, what is it? Why do we need it? Why does an organization need it? I hope that's a bit clear. It's application level, so it doesn't mean that you don't need that network layer security. That still exists and that still is very much needed. Then we looked into also how does such a platform look like and the trends that we see today. And that's a challenge where we are now at many of our organizations, at our customers, and how can we adopt that API management platform to the new challenges of today. Voila.
Okay, thank you very much, Samuel. At least very clear to me. And now I can introduce Teun. And Teun, maybe you can introduce a little bit about Salt and then go ahead. Yeah.
Thank you, Sjoerd. Thanks everyone for joining the live hack demo. So much at stake to watch, actually. The demo part. Okay. Also, the slides turn a bit to black to get a bit of the hacker mentality out of you. So this is me, Teun Westbroek, part of Cronos Group, working at Salt Cybersecurity. We focus on secure by design. So we first think of building it, think of the security, because this image tells it all, I would say. This is your security measurement, right? This is your asset. Do you buy something to protect your asset that's way much more worth than your asset? I guess no, right? And that's security is all about. You protect something that's worth to you something, so you have a budget to protect it. And that's where the hackers come in, because they are after your asset. And the easier it gets to get to your asset, the likelihood, the impact it has on your asset, is your risk score. And basically the risk, it's just a quantification or qualification, but if both are high, it's a high risk. And nothing else with API management. So before I get into the demo, just to give a bit of the context, the slides are in Dutch, apologize for that, I'll translate it. These are, if you ask me, the top 3 risks. As we introduced, APIs are more and more publicly exposed, meaning publicly exposed, reachable for everybody in the world, right? You only need a network connection to the internet and you can access APIs. That's the likelihood. So for attackers, it's easy to get there. And then the impact. We have impact on data leaks, querying APIs, providing information to the API to get more data than the API was actually designed for to deliver. Or the second one, manipulating objects. For example, I register as a user. Let's try to put the is-admin flag to true to that. Do I become not a normal user but an admin? I'll go to show you. And the last one, I think rate limiting was mentioned. You want to protect yourself from outages. And it's easy nowadays to basically make systems unavailable by calling APIs, and a heavy API meaning an API that has a big footprint on your infrastructure. If you call that many times, you don't need like a whole botnet network, maybe just one machine. I can basically bring down your whole infrastructure. So let's go to the demo part. You just need to switch to the first my Wi-Fi hotspot. 1 second. Bear with me. Then I'm going to switch to PC screen. it should work, normally. Oh, there it is. Just in time. Okay, so our demo environment basically is, first part we have a web shop. So I'll show you a web shop. But it's not a normal web shop. It's called the juice shop. It's leaking juice actually. And maybe you know this. Who knows the juice shop? Some of you know, right? Really popular for ethical hackers trying to find vulnerabilities. And there are actually API vulnerabilities in there. That's why it makes such a nice example. So this could be any web shop, right? Coolblue, bol.com. Any web shop, modern web shop that has APIs. So what, maybe a lot of people here that attend cybersecurity sessions like this, and you want to register for the event, just be honest, who presses the F12 button to open the developer tools? Yes, I see a lot of hands. So we do that here too. And if you ask hackers, what are interesting point to start? Well, searching, because it expects input. So let's search for a banana. And that's a normal query, nothing wrong with that. But now, it should have recorded well, it's not showing here. Oh, it is, it's showing here. Okay, let's show later. Basically, it shows under the hood a query. And that same query, basically, I can try to manipulate to see, can I put something malicious in there? Not banana, but maybe something else. And what is that something else? And in that case, I just switch over to a Postman. Postman is doing the same thing as your browser, right? So I can send the same query, which you saw from my browser. And while the browser is presenting the banana juice, nice to a user, this is the output from the API. So now I can utilize my, basically hacking is about creativity, right? Maybe that's a database behind it. And maybe that database and all application on top of it is vulnerable SQL injections. And guess what? It is. So if you look at this query, it's doing a union select. Not sure who is aware of that, but basically it means that if you do a query and the application thinks, oh, that's a valid query, you can actually query the underlying database and append the results. In this case, I'm just requesting the product database. I'm also requesting all the users and all the passwords, right, behind this system. So I'm going to send, and now guess what? I get all accounts, all registered users of this web shop. So this is then, basically this will get to the news if this is like Coolblue, bol.com, all customer information is leaked, right? But it's getting worse. In this case, the passwords are in not a really good hash. So everybody who knows crack station, what is the password? Well, crack the hash. I'm not a robot. Did it find it? Oh, this is the password, but okay. Is it this a normal user? Jim. Maybe there's another user. Well, admin, right. That's interesting. So you can do the same thing, right? And now I can crack the admin password too, which is not a real strong password, I have to say. Basically, this is what hackers do, and this will not hardly get notified. You need to have something in place to protect your web application firewall, right? And which is normally done by a web application firewall that detects basically incoming malicious payloads like a SQL injection. So in here, I'm going to show how you can actually enable and protect the API. And going to the protected route, trying to do the same thing. And actually you can see I've been blocked. Ah, too bad. So now you can actually see that I put basically a layer around my API, a runtime security layer. So the browser talks to the API, and now I've placed basically a wrapper around it, a security wrapper. The nice thing is, it does much more than protecting malicious payloads. And that's the story about API management. You want to think before about your design of your APIs, which fields are basically came back from the response, which field I can provide to the response. And that's more advanced API management. And something I'll show now. Because this is the malicious payload, but there are a lot of queries you can do, and it won't detect it because it's actually a normal payload. For example, if I'm going back to the juice shop, and I want to look how basically when I register myself, just as a normal user. Oh. Let's put it like this one. Oh, something now blocked. Okay, that's what demos happens all the time, right? Let's just go to the what I would normally do. So in this case, I wanted to show was if I create a user and I monitor in the backend what's actually going over the line, then you can basically see the normal fields. And as a hacker, I could add other fields too, just to try it. For example, if I register as a user, I will be a normal user in the web shop. But this time, if I put in the sysadmin flag, which should not be part of the API specification, but actually the backend honors it. So that means that as a normal user, anywhere in the world, anybody in the world could register as an admin and has admin access to the web shop, which is not good. To basically protect against these kind of attacks, you have to basically think upfront, how does your API schema look like? And let's get a bit technical maybe, but to give a brief example, an API schema basically means what is allowed. It's basically a policy. What is allowed to your backend? Which kind of fields are required? What is the data types of those fields, and what rules are further provisioned? So this is the technical explanation for JuiceShop. When you register a user, only expect these type of fields and not like the sysadmin flag. And now in modern API protection platforms, you can actually import those rules in your API shield. So let's look like here. So that same file that I just showed, I can basically upload. And now it automatically will read it. And basically, you can mention something like, what should the action be? For example, if you have your API and you want first to say, well, I don't want to block because I'm not too confident yet that my schema is good enough. I'm going to put it in log mode first. Meaning that way you can already have your eyes. You see what data is coming in your API, and you can also see what is normal behavior and what is malicious behavior. If you're at that point are really confident to say, okay, this is the right specification. It's called the whitelist approach. It only allows data from according to the specification. You can put it into block mode, and at that point, you add it to your to your API protection platform. In this case, Cloudflare. There are other vendors. We at Cronos, we are a Cloudflare authorized service delivery partner. So this is basically eat your own dog food, try it out and show it. And now you can actually see that and I've did it as a way to have it in place already, that you can actually see that it blocks now my malicious attempts. So that's why it did not work in the first place. I forgot to remove the protection, so it worked. That basically concludes my demo for now. Hope you have any questions. Feel free to ask after. Look for Cronos Security booth in the room over there. Thanks for everyone for attending.
So thanks, Teun. So yeah, pretty much I think I could do a hack myself. And I'm not a technician, but I have a browser, and I am pretty sure I can download Postman as well. So thank you very much. So the next speaker is Matthias. Matthias, the floor is yours.
Thank you, Sjoerd. Just waiting for the slides to come up. Almost there. Right, let's go. Thank you. All right, good afternoon, everyone. My name is Matthias De Scheerder. I'm working for Archers, which is also a company within the Cronos Group. We are focusing on integration architecture, integration analysis, observability as well, enterprise architecture. But our core focus is integration, and that's one of our specialties is API management. And then, of course, API security is an important part of this of this expertise, let's say. So, yeah, I'm an integration architect myself and a managing partner of this group. Now, as Samuel and Teun already showed you, it was quite a technical view, an intro on API management and where it is going and how API security is important, on what we can do to hack APIs and protect ourselves against those attacks. Now, this is all like technical knowledge that you can assemble, but the question then is, once you have that knowledge in your organization, what are you going to do to make sure that the APIs that are delivered, that they're actually that they contain all of that knowledge that you have gathered, all of the agreements that you have made, all of the ways of working that you have defined. How will you control that? How will you make sure that you deliver quality and consistent APIs? And that's where we have made up our API program. And that's basically because when we're talking about API management, then it's often seen as something technical. Like the API platforms and the APIs themselves. It's seen as technical construct. But it's actually, it goes way further than that. And when we help customers and organizations with API management, this is what we use as the background to make sure that we don't forget anything. We have these 6 pillars in our program, and they start from the strategy. They start from the business. We want to know, we want to define what organizations, why they are doing API management, what the drivers are, what their goals are in API management. And this is important because this will determine quite a bit of the decisions that we will make in the other pillars. Governance, this is about delivering your APIs with quality and in line with the guidelines. We have the platform. I think I don't need to explain this, and the API management platforms, the toolings, but also the capabilities that you will unlock on those platforms. We have the organization. You need to have your organization, your teams, your users, your roles in place. Design and realization, this is about providing guidance and assistance to your developers, to your architects, to your analysts. And then we have the marketing and evangelization part, which is basically all of the things that you have built up in the first 5 pillars. Your approach is going to fail if you don't manage to spread the knowledge, spread the ways of working within your organization. And the marketing pillar is what is going to help you in doing that. Now, I won't go into detail in all of these pillars because I don't have the time for that. But I will highlight a few that will help in, let's say, governing the quality of your APIs, making sure that they are delivered in a good and secure way. And then the first is you need to govern your delivery process. And I think when we typically talk about governance, then often some eyebrows are raised because governance is sometimes seen as something that is a burden, a bottleneck maybe. It slows down delivery, and even more so in the current ways of working, which is usually agile ways of working. So governance is sometimes has a negative meaning to it. But we do feel that there is some level of control needed in order to make sure that your APIs are delivered in a good way. Because there's quite some challenges. You want to make sure, for example, your contracts, your open API specs, you want them to be consistent. You want them to follow the guidelines. Retirements. When you pull an API out of production or a major version out of production, you want to make sure that, for example, they are not used anymore by consumers. You want to have solutions that are uniform, working in the same way. And then when we look at security, you want private data and sensitive data to remain private. You don't want them to be breached. And you want, of course, if you're securing your APIs, you want them to be secured in the ways that you have defined. So that's why we are looking at API governance as applying the standards, applying policies and processes that you have defined within your organization to ensure that your APIs are standardized, that they are reliable, and that they are secure. So we have this base governance framework. This looks quite heavy, maybe, but this is basically serving to guide the APIs throughout their life cycle and make sure that in each step that we install the proper controls. So this is from doing an identification checkpoint to make sure that the scope and the functionalities are in line and that they are well thought out, that maybe you're not creating double or overlapping APIs. And I hear quite some sound from the outside. Yeah. We have a contract checkpoint, for example, to make sure that the open API specs, that they are consistent, that they are following the guidelines. We have a publication checkpoint, for example, where you're going to make sure that before we go in production, that all of the steps have been followed. Testing all of the necessary checks, all of the necessary security certificates, for example, that they are ready for production. That's what we can do there. And then the retirement checkpoint, for example, making sure that an API isn't used anymore by consumers. Now, this is very much a base framework. It's not take it or leave it. We don't go to organizations and say, this is your governance framework, have fun with it, bye. That's not how we do it. It's the basis for discussion. Each organization is different. The people and their skills and capabilities, the processes present at an organization, its internal structure, the internal and external context, or even things like legislation that have an impact on the organization. That's different for all of the organizations. So we have this framework that provides the basis for a discussion, but we need to craft and adopt it for each organization specifically. For example, Within banks, we are going to often see a much more stringent governance process than we see in smaller startups, for example. It's going to be different, but we need we need to have the discussion, and we need to have some form of control. The next one is the organization structure. In our organization pillar, here we're talking about two main building blocks. We have roles and we have teams. So the roles are going to define what individual people will do, where people can have different roles. It's not a one-on-one relationship. So in smaller organizations or smaller teams, people can have multiple roles, but it's important that you define the roles that you need, and you define which people will carry which roles, because in the end, it's about the people knowing what they have to do. And then we have team structures that defines how people and teams will work together. So this also depends on the organization size. It depends on the internal knowledge available and the internal capabilities that you have and the overall strategy. To visualize this a bit, when we are talking about API management roles, then we have the typical one. We have developers, testers, analysts, architects. I don't think I need to explain a lot about that. But we have some specific roles when it comes to APIs as well. An API champion role, for example, can help you in advocating the usage of APIs. So for organizations that are starting out with APIs or that want to raise their API maturity and take it from a technical level towards a more business-oriented level, then an API champion level can really help you in spreading the enthusiasm about APIs in the organization. An API product owner, for example, from the business side, can be the responsible person to make sure that your APIs managed as a product, that you are building the right ones. And then the partner manager is when you, for example, when you want to work together with external partners, when you want to open up your APIs towards external organizations, then a partner manager can help you capture what they need from you and can help them with connecting to your APIs. So when talking about the team structures, then there are several ways to deliver your APIs. We can have everything centralized in an API team, which has all of the capabilities in a central team. This is good to start out and to experiment, but isn't going to scale very well within organizations. We have a factory-oriented team structure where we have centralized development capability, but we have the business product manager, the product owners in the business domains. And so this is often used, for example, when organizations do not have the internal knowledge to develop APIs themselves. So they bring in external consultancy, for example, and this is called the factory. We can have a central platform team and the development teams that are within the business domain. So the development teams are close to the business; they know their business, and so this scales better than the centralized capability. And then for real mature organizations, we have the decentralized capability, where basically you're going to put the development capabilities and the platform capabilities in the domains, so they can be very autonomous. This is for organizations that are very mature. Okay, so guidance. We want to make sure that, like I said, the APIs are delivered in a consistent way, that they have the same look and feel, that they follow the same guidelines. And to follow the same guidelines, of course, you have to define guidelines. And that goes from guidance towards your architects, for example. You need to make up your reference architecture or something like that, so that people know which capabilities they need to use in which on which tooling, but also what will your API layering look like? There's like the internal APIs, external APIs, partner APIs model. You can have the system APIs, process APIs, engagement APIs model. So there's different ways to structure your API landscape. And that's what you're going to put in a reference architecture. And then you're going to map that to your capabilities, more your technical platforms. This is also where you will map your security capabilities. Samuel mentioned that you can do like the application level security on your API gateway. And that's a possibility. You will also have network level security. So where are you going to put and activate all those capabilities? That's something you should think about and put like in this reference model so that your architects can draw out your solutions in the same way, in a uniform way. And of course, provide guidelines. I'll give just one example, maybe versioning. I've had in most organizations that we start talking about versioning. This is always a hot topic. How will we version APIs? Will we do major, minor patch versioning? Will we put the major version in the URL or not? Things like that. It's always, everyone has their own opinion. There's never really the answer, which goes for most of these guidelines, of course. There's not really one answer that is true or correct. But the important thing is you need to do a set of guidelines and just agree to use them, even if not everyone is on the same page about an exact small guideline, for example. You just need to use the same ones and it will work. So that's what you will provide to your, for example, your Open API designers. Security guidelines, of course. There's a lot to be said about API security. It goes from authentication, authorization. We have application layer security. We have transport layer security. We have information security. So there's a lot to create guidelines about. Because if you don't provide these guidelines, then basically everyone is going to freewheel and you're going to end up with a lot of different solutions, and then it will be hard to manage. So think about these guidelines. Think about the building blocks that you have available within your solution with regards to security. And also think about, we call it the confidentiality integrity matrix. Where are you going to apply which security level, and what will those security levels mean? We're not going to go into detail here because again we don't have the time for that, but this is really important stuff that you should think about when it goes about when we're talking about API security. So at this point, we have defined a lot. We have defined why we are doing this. We have defined what our governance process will look like, what the organization will look like, what your guidelines will be, what your reference architecture will be, what your technical platforms will be. So that's quite a lot of work that is done. And it would be really a shame if this doesn't succeed, then this setup, because this is a big approach. This is a lot of work that you've done, and you need really to spread the word. So important here is to create a central source of information where all of the things that you basically have decided and discussed, that you put it somewhere where it's easily reachable. Because if people find it easily in one place, then the chances are higher that they are actually going to use it. Whether that be on some kind of wiki page or on Confluence or even SharePoint, it's possible. But make a decision and put it somewhere. I would advise not to put it in Word documents somewhere in a folder structure in SharePoint. Not that. Some wiki page alike things that works best. but make a decision and actually do this. Huh? If we've seen in organizations that they had like all of these, and that information was spread on all of these sources, and then you get confusion because there will be overlapping information, there will be missing information. Some people won't know that one of these even exists within the company, and then they will miss the information. So one central source of information is important. Training paths also important for the roles that are active within the organization. Some path. So this is an example of a modular training path that we made for one of our customers, where we started with some. It's modular, so some are shared for all of the roles, and then some are specific for some of the roles. It doesn't have to look like that exactly, of course, but when you onboard someone, when you onboard an API developer, make sure that the knowledge is available, and that your security knowledge also is put somewhere, and that they can easily reach that material, they can get trained, and they can get started. Now, of course, when you start with API management, but also when you've been doing it for a while, then you're not necessarily at the highest level of maturity yet. Maturity is something that you need to build step by step, and with maturity comes experience, or with experience comes maturity, and you will need to build it up as well if we're talking in the context of security as well. The more experience you have, the more mature you are, then the higher chances will be that you are delivering APIs that are secured in a good way. So we have this maturity level, or maturity model, let's say, that is composed of five levels, where level 1 is the level, the lowest maturity level, level 5 is the highest. And what we see is that basically in the lowest levels, we are more working in let's say, a project-driven way, an IT-driven way. APIs are created here on an ad hoc basis, on an as-needed basis. And when we move up towards level 5, then they are really a strategic part. They are even seen as a productized part. So the API as a product. We see the tipping point is around level 3, where this business thinking, this business-driven way of creating APIs is really present. That's where we see the business models coming up for using them, and the participation, for example, in ecosystems. When you want to drive innovation within an external ecosystem, then you will need some maturity, because that's where your APIs are going to be heavily exposed, heavily used, and need to be well regulated and very well secured. So when we relate this a bit back to the API program that we saw, then what we see is in the first few levels, we are basically talking about building the API right. The technical means, the platform, the knowledge to actually build APIs. That's where we are basically focusing on and building maturity here. When we get to that tipping point, when we start to move over towards the business-driven way, we are more doing, let's say, we are more about building the right API. We are thinking about how they should look like, what APIs are we building, what products are we building here. That's what we're shifting towards. And so this is our full API maturity model. We see that we have the levels on one axis, and we have all of our pillars from the API program on another axis. And here we use this to support organizations in determining, in assessing where they are now, in which maturity level they are themselves now, and which level they want to go to. And once we know those two, then we can determine the steps and the roadmap in order to get there. Because, and I should be clear about this, the end solution or the end goal isn't necessarily to get to level 5. The highest level might be a bit too much, a bit too heavy for organizations to reach. So we'll determine together with the organization to see which is the level they want to reach. Typically, what you see is on level 1, we are more in a technical way, a reactive way, in an ad hoc usage of APIs, or within certain isolated teams within projects, they are doing some APIs, but it's not strategic yet. There's not a lot of governance yet, and there's no standardized process. And as we move throughout the levels, as we move towards more like level 5, then it's really going to be something that's inherent in the organization, that we have a formalized governance process, and that creating APIs is part, not just part of the IT organization, but also part of the business mindset. So we talked about this rising in maturity. We set a goal, a target with the organization. For example, we want to go to level 4, and then we can start defining actions, defining steps that they should take in order to get to that maturity level. We will then chart these into actions along the axis of business value and maturity value, and then we can put all of these into some kind of, let's say, value enrichment matrix as well, to see what we need to tackle first. When we put this all together, then we can, with the help of this Archers API program and the maturity matrix, we can help organizations to build up a roadmap based on the maturity scan that we have done. And I think that will conclude my story, so I will give it back to Sjoerd now.
No, many thanks, Matthias. So to put all things together, what we have shown today is, first of all, that how easy it is to actually exploit poorly deployed, developed APIs, and that there is a quick fix protecting your APIs on runtime, something which Teun showed with Cloudflare, and there are other products you might want to use or explore. Then Samuel explained how API management can play a role in actually controlling the deployment management of your APIs, and also how the developer portal can help to prevent the existence or need for rogue APIs. Also a very big security issue. And last is if you want to get to the root cause and make sure that all your APIs are developed and delivered in a good quality process, and also very well designed, then there's an API maturity program which might help you to get to the next level and make sure that you solve all things from the root cause up. All our contact details are on the slides. I'm also in the session browser, so please reach out if you like to receive the slides or want to have a follow-up of this session. And I thank you all. Are there any questions of you? Okay, we're at the booth, so don't be afraid to come to us. And there are some goodies there. So if you want to bag or just a dupper, just grab one on your way out. Many thanks for your attendance. Okay.